Hi everyone. So moving on, this lesson here is going to look at the tangent ratio. And we know that there are two other ratios, the sine and cosine ratio. But for this lesson, we're strictly going to stay on the tan ratio. Okay, so remember we have these 90-degree triangles. And there's the symbol. And we have some reference angle theta. And the point of trigonometry is to relate this angle to the sides of the triangle. So we said the long side of the hypotenuse across or opposite theta is the opposite side, and the other side just beside theta is adjacent. Alright, but if you move theta, if you put it up here, you have a whole other set of referencing to do. Now opposite theta would be over here. Again, we said it's like these guys are two goalies who face each other. So theta's opposite's across from him, like a goalie would be across another goalie. Same as over here. Okay, so if we know that this is opposite, we remember that hypotenuse never changes, and this is adjacent. And tan, or tangent, so the tan of theta is the opposite divided by the hypotenuse. Okay, and we remember it as TOA from SOHCAHTOA, or I write it this way, TOA. Okay, remember the memory aid to remember all three main trigonometric ratios. Sine, cosine, tan is SOHCAHTOA. Today, though, we'll only look at tan. So we won't have to make any decisions. It'll predominantly, through all these examples, work out to be the tan ratio. So let's do example 1 here. In the examples that we've done before, we were never given the angle in a 90-degree triangle. Now we are. So let's tackle this. They want us to find side x in this 90-degree triangle. Okay, so if I'm referencing off angle 35 degrees, let's take stock. Across from 35 degrees, I have the unknown side x, and that's across from it or opposite it. And we said that beside this reference angle is the adjacent. And, well, we don't know this long side, and we call that the hypotenuse. That's okay. If we think about the tan ratio, T for tan, O for opposite, A for adjacent, we only need the opposite and the adjacent. And, well, that's good because we know the adjacent, it's 8. And x, which is the side we want to find, is opposite. So if we write it out, we get the tan, in this case it's the tan of 35 degrees, is opposite over adjacent. And we're going to first put in our opposite and our adjacent values. So the opposite in this question is the unknown, x, and adjacent has a value of 8. Okay, so to solve this is actually quite easy. Who remembers cross multiplication? The idea is that you kind of imagine this as a fraction over 1, and you can cross multiply. It's actually an easier version of cross multiplying. You just have to do the following. Okay, so cross multiplying means you would multiply 1 times x, and then the tan of 35, which has a value, times 8. But 1 times x, that's just x. So we really don't need to do that here. What we'll instead just do is we'll take 8 and we'll multiply it by the tan of 35. And that's all you really need to do. Because 1 times x, well, that's just x. But 8 times tan 35, we're going to have to work that out. So you write 8, and all you write is tan 35 degrees. It means 8 times the tan of 35 degrees. And that has a value, so let's find out what that value is. Tan 35. Grab your calculator, guys. Make sure it's in degree mode. Tan of 35 is 0.7002. Okay, and then work out what x would be if 8 multiplies 0.7002. And you get 5.6. I don't see any units, so I'll just say 5.6 units. Let's look at example B. I'll set it up, you try it, and then you can check your answer against mine. So again, we want to find side x. This time the reference angle is over here. It's 15 degrees. You go through the steps. So identify who the opposite is. Opposite to 15 degrees would be the side with 5. This is the long side, and he's across the 90. That's the hypotenuse. And this side here is the other one. We call it the adjacent. And once again, we have no information on h, and we have opposite known as 5, and the adjacent is x. So you're dealing with O and A fall under tan. The tangent is op over adjacent. The tan is op divided by adjacent. So work that out. Follow example 1a, and pause the video and come back and check if you got it right. Okay, hopefully you tried this. You might have gotten a little messed up with the one part, so let's take a look at it. Tan 15 degrees is op over adjacent. You put in the numbers in the variable. You get tan 15 degrees is 5 over x. And it's a bit different here than it was here, because x was in the numerator, here it's in the denominator. Still, you cross multiply. And it would look like this. So sort of like there's a 1 here. And you go 1 times 5, and tan of 15 times x. So this is how you show it. So tan 15 times x okay, we'll say a dot for times x, and 1 times 5 will go here. Now remember, we want to find x, but tan of 15 degrees is multiplying x. So what you're going to want to do, you're going to want to divide out tan of 15 degrees. On both sides. And when you do that, it cancels over here. And then you need to work out the math. You'll have x equals to 5 divided by tan 15 degrees. And you can actually put that right in your calculator. You grab your calculator and you do the following. 5 divide by tan 15. Okay? And you get 7 if you round that. 18.7, we'll say, units. Okay? You could have also done, like, what's tan 15? And it's 0.2679. So you'd have to remember that, and you'd have to do 5 divided by 0.2679. And you'll also end up with 18.7 units. Okay? So a bit trickier. Hopefully you tried it. Even if you struggled, now you see how it's done. It's not that bad. Example 2 wants you to find angle A and angle C. So it looks like angle C is actually theta. You could make angle A beta. Sometimes we just call it angle A. Sometimes we actually use a Greek variable like beta. Or there's others too. We saw alpha not long ago. Okay, so since it started us off with angle theta, let's reference off him and cross or opposite theta, again, it's like this guy faces this guy, they are opposing each other, so 9 is opposite. Okay, the long side's hypotenuse, this is adjacent. So again, we're doing a tan lesson, and it's going to work out that off of theta here, we have the 9 as our opposite and 5 as our adjacent. And that's what we want, opposite and adjacent. We have those two. So tan of theta is op over adjacent. Tan of theta is, well, 9 over 5. Okay, here's another way of writing this. If you want theta, you want to do tan inverse of 9 divided by 5. And I just didn't convert it to a decimal yet. So with your calculator, you can do this. You can say shift tan, and I use brackets, 9 divided by 5, and it will immediately give me the answer. So that's 61 degrees if I round it to a whole number. Okay, and we have angle C. C's theta. How do we get angle A? Do we want to go through another trigonometric ratio? I don't, because I know angle B, 90. I know angle C, 61. And I know the whole triangle adds up to 180. So I just use that fact. Okay, so beta makes use of the fact that a triangle's angles always add to 180. So I take 180 degrees, take away 90, take away 61 degrees, and beta, which is my angle C, what's that work out to? 29 degrees. For question 3, you should try this. I'll just set you up a little bit and give you the answer. So the diagram essentially follows from the word problem here. You've got a 58-degree angle and the side that's adjacent, so I already told you that, which makes sense. If you have 58 degrees, that's adjacent, is 9 centimeters away. So we do have units here. Following our rules, if that's the reference angle of 58 degrees, opposite that would be unknown side x. So the opposite side is like x. Okay? And they want you to find it. And we have no info on the hypotenuse. You'll use a tan ratio. And once you do all your math, your answer is x equals 14.4 centimeters. So try it. Let's go do number 4. So in example 4, we're going to start moving into applications. All the trigonometry that we're using has its place, obviously, in the real world. And now we're going to start bridging that gap between the math and actual applications. So we've got a ladder rested against a tree. The foot of the ladder is 1 meter from the base of the tree. So there's the foot of the ladder, and it's 1 meter from the base of the tree. So let's add 1 m there for 1 meter. And it forms an angle of 64 degrees with the ground. Well, there's the ground. So this angle here, maybe we'll just say it's theta, but theta equals 64 degrees. Okay, so there it is. So I've labeled the diagram. How far up the tree does the ladder reach? Well, that would be how far up the tree. And they want the nearest tenth of a meter. So that's the basic unknown they want. We'll call it x. Okay, and I mean there's a triangle there. They're not for real, but we model this with a 90-degree triangle. So in the real world, there are many situations that you model. In other words, you kind of impose a 90-degree triangle on it, to use to solve the given question. So how far up does the ladder reach up the tree? And essentially you should see this diagram. I'm just going to draw it out again. As a math only question, you have a 90-degree triangle, 64 degrees, that's 1, this is unknown. If you're using all the techniques we've discussed in today's lesson with tan, you'd find this. There's your reference angle, he's opposite, hypotenuse is unknown, this is the other side, we call it the adjacent. So the two values we're dealing with are op and adjacent. We want to find op. Adjacent has a value of 1. We need the tan. So we're going to say tan of 64 degrees. And remember, tan is TOA, op over adjacent. So tan of 64 degrees is x divided by 1. And we cross multiply, but really there's a 1 here, so there's really nothing to cross multiply with. We can still show it. 1 times x is x, and 1 times the tan of 64, well, that's just really the tan of 64. So let's work that out. What's tan 64? So tan 64, 2.05. They want nearest tenth of a meter, so 2.1. And we realize that x is 2.1. We're in an application, so x has to have a unit, and that's meters. Okay, and you would then summarize the ladder. Reaches 2.1 meters up the tree. Something to note, this does not come from our textbook, and don't worry about this reference, okay? And we'll perhaps look at question 5 or something similar in class. So bring your questions. There's some practice work that goes with this. See you soon.